this video we will learn how to decompose the price effect into income and substitution effect using Hicksian method. The question is, a consumer has the utility function u is equal to 40 a raised power 0.5 times b raised power 0.5. A and b are the two goods consumed by the consumer. The prices of two goods are, that is, the price of good A is $20 and price of good B is $5, and the consumer's income is $600. The price of good A falls to $10. Find out the income and substitution effects of this price change using Hicksian method and say whether A and B are normal or inferior goods. Okay, so let us see what the information we are being provided. We are being given the utility function, that is utility function. Utility derived by consuming good A and B are related like this: 40 times A raised power 0.5 B raised power 0.5. Okay, also we are being told price of good A is $20, price of good B is $5, income of the consumer is $600. Also we are being told that the price of good A has fallen to $10. Let us denote it by like this: price of A prime, it has fallen to $10. We need to find out the price effect, and we need to decompose it into income and substitution effect using Hicksian method. Okay, so let me draw this graph here to make the things easy. So we have good A on the horizontal axis, good B on the vertical axis. Okay, so what will we do here? There are two things. First, we need to find out the initial optimal bundle without price change. Since we need to, and what is meant by the income and substitution effect? So let me say it briefly. Now income effect tells us how much the consumer consumes of a good if the purchasing power of the consumer changes. Okay, and substitution effect is how much units of a particular good will a consumer consume if the relative prices of the goods change. Okay, I will not go into detail here. I have explained the income and substitution effects clearly in earlier videos. So first thing is, what we need to do, we need to find out the initial optimal bundle. So for that, so I need to find out the initial optimal bundle. Initial optimal bundle. For that, what we need to do, we want to maximize the utility of the consumer, that is 40 A raised power 0.5 times B raised power 0.5, subject to the budget constraint. What will be the initial budget constraint? That will be price of good A times units of good A plus price of good B times units of good B should be equal to the income of the consumer, and specifically price of good A is initially 20, price of good B is 5, and it should be equal to 600, such that subject to the budget constraint, that is 20A plus 5B should be equal to the income of the consumer. Okay, so we want to maximize the utility. For that, now let me draw the initial budget line. Let us suppose this is our initial budget line. Let us give it a name CD. Okay. Now with the initial budget line, consumer wants to reach to the highest possible utility. Okay, and the initial optimal equilibrium will be when the marginal rate of substitution, between good A and B is equal to the ratio of the prices, price of good A upon price of good B. We know that very thing. MRS is, as we know, it is the marginal utility of good A upon marginal utility of good B, and it should be equal to price of A upon price of B, that is 20 upon 5. 20 upon 5. Okay, so mu means the derivative of this, MUA means the derivative of this utility function partially with respect to A. And let me show what will be the marginal utility of good A here clearly, because we will need it. So differentiating this partially with respect to let me clearly show here first, and I need to wrap this because I don't have the space to align all the things here. So what we need to do, we need to equate the marginal rate of substitution between good and A and B with the ratio of the prices, price of A upon price of B. MRS is simply the marginal utility of good A upon marginal utility of good B. It should be equal to the ratio of the prices, 20 upon 5. 20 is the price of good A, 5 is the price of good B. Marginal utility of good A means the change in the utility due to the change in the consumption of good A. Likewise, marginal utility of good B means the change in the utility due to the change in the consumption of good B, and it should be equal to 4, which is the ratio here. Now du upon dA means the partial derivative of this function with respect to A. Now the exponent of A becomes coefficient, so we have 40 times 0.5, then the exponent of this will be subtracted by 1, so 0.5 minus 1 is negative 0.5, and B will remain same as 0.5 because we are taking partial with respect to A. Likewise, du upon dB means the partial derivative of this function with respect to B. Exponent again becomes coefficient, so we have 40 times, so exponent is 0.5, it becomes again coefficient. A raised power 0.5 will remain same, but the exponent of this will be subtracted by 1, so it becomes negative 0.5. 40 gets cancelled, 0.5 gets cancelled. Now let's transpose this B here and this B there. So what will happen? So exponent signs will obviously change. So we have B raised power 0.5, this times, if I transpose this, it becomes B raised power plus 0.5. Likewise, here we have A raised power 0.5. If I transpose this, it gets multiplied, but the exponent of this changes from negative to positive. A raised power 0.5. So bases are same, we can add the exponent. So we have B raised power 0.5 plus 0.5. Likewise, here bases are same, we get A raised power, we can add the exponent 0.5 plus 0.5. So we will get ultimately B upon A. So this whole stuff comes out to be B upon A. That is MRS between A and B should be equal to ratio of the price of A upon price of B. And MRS came out to be B upon A. Let me rub this now out. So MRS came out to be B upon A. So B upon A should be equal to price of A upon price of B is 20 upon 5. We calculated it as 4, which implies B will be equal to 4 times A. Now plug this value into the budget constraint. So what will we get? So we have 20A plus 5, the value of B is 4A, should be equal to the income. Income is 600. Okay, 600 here. So we get 20A plus 20A is equal to 600, or 40A is equal to 600. 4 gets cancelled, so A will be equal to 60 upon 4, which is 1 upon the 3 shared. So we'll get A is equal to 15. So initially we get A will be equal to 15 units. And what will be B? Since B is equal to 4 times A, so B will be equal to 4 into 15, which is equal to 60. So B will be equal to 60. So initially the optimal consumption bundle will be, consumer will consume 15 units of good A and 60 units of good B. So on the graph, what exactly it looks like. So let us suppose this is the point where we met the tangency condition. That means if I draw, this is our indifference curve, initial indifference curve. Okay. At this point, what exactly happens? Consumer is consuming 15 units of good A and 60 units of good B. Okay. Next, we need to find out the new optimal bundle, or we also need to find out the utility, total utility derived by consuming good A and good B here. So let us find out the utility also here. Now what will be the utility? Utility will be equal to, plug 15 and 60 in this equation, so we have 40. So utility derived will be 40 into A raised power 0.5 what is A is 15, so we will get, so A raised power 0.5 is, A raised power 0.5 is under root A, we can write it like this, so let's write it here 15, and B is 60, so 60 into 15, 60 into 15 is 6 5s are 30, 6 1s are 6, 7 8 9, so it is under root 900, which is 30 into 40, so we have 40, so we will get 1200. So what is the utility derived? It is equal to 1200 units. Okay, we need this stuff here. So we found out the optimal initial bundle. Next we need to find out the new optimal bundle. How do we find out the new optimal bundle? Now what will happen here? Second thing is we need to find out new bundle, new optimal bundle. Okay, for that what will we do? Since price of good X has, price of good A has changed to 10, it has become cheaper, so consumer will consume more of good A. Okay, so again, and let me write, since price of good A is this time 10 units, initially it was 20 units, that means consumer will consume more units of good A, that means our budget line CD will pivot towards right. So how do I draw it here? So let me draw the pivoted budget line like this. So let us say it is C D E C. This is our new budget line. Now what we need to do, we need to find out the new optimal bundle on this CE line. Why it has pivoted? Because the price of good A has fallen, that means consumer is able to purchase more of good A due to falling price. New optimal bundle we need to find out. So again, what we need to do, we want to maximize the utility. Okay, so again we want to find out the new optimal bundle. What we need, price of good A is 10, price of good B is 5. Okay, and income of the consumer is again same, income is 600. We need to find out new optimal bundle. Again we will equate MRS between A and B with the ratio of the prices, that is price of A this time, which is price of A prime, divided by price of good B. MRS we calculated, it came out to be B upon A. It will remain same, B upon A, and it should be equal to new price ratio. So we have this time 10 upon 5, which is 10 upon 5, which is the price of good A prime, the price of good B here. So it will be equal to 2. That means we will get B is equal to 2 times A. Now we plug this value. I forgot to write here budget constraint. Why? Because Magzentas joyous need, because I had not space here available. So what is our new budget line? That will be price of good A times units of good A plus price of good B times units of good B should be equal to the income of the consumer, which is 600. So price of good A is this time 10, so we have 10 A plus 5B should be equal to 600. Now plug B is equal to 2A here. Okay, don't get confused. To find out the new optimal bundle, what we need to do, we need to I hope you are not getting confused here. So this line I have to write first here, okay, and the utility function like this, maximize utility subject to the budget constraint. Again, maximize utility subject to the budget constraint. I don't have the space. I have calculated MRS and equated, we got this relationship between B and A. Now plug B is equal to 2A in this equation. So what will we get? If I plug, so we have 10A plus 5 into 2a is equal to 600. So 2 5s are 10, so 10a plus 10a is 20a is equal to 600. So a will be equal to 30 and b will be equal to 2 into a, so 2 into 30, which is equal to 60. Okay, now after doing this with new prices, what we got a prime new optimal bundle for good A will be 30, and for good B it is B prime, it is 60. Okay, so let us suppose we have at this point, we are at this point when we maximize the utility of the consumer subject to the new budget line. So it is not perfectly tangent here, so this is our new budget line. So at this point what happens, consumer is consuming 30 units of good A and again 60 units of good B. Okay, so initially consumer was at this point, let us say this is point 1, consumer has reached this point, let us say this is point 3. Okay, so this is the price change when the price of good X has fallen from 20 to 10. Consumer is consuming 30 units of good X against 50 units which he was earlier consuming at prices 20. Okay, so this is our price effect. Now what we need to do, we need to decompose this price effect into substitution effect and Hicksian effect. Now we need to find out the Hicksian change here. Okay, so what we need to do, we need to find out the substitution effect. The substitution effect is the change in the consumption of good A due to the change in the relative prices holding utility constant at initial level of utility. What is meant by this? We need to find out the compensated income that would allow the consumer to achieve the initial utility with new prices. That is what we will do here. We will since consumer is at this point, we need to compensate, or we need to take away income from the consumer so that he is able to get the initial level of utility. Obviously here the utility will be greater than this. Now what we need to do, we need to find out the compensated income that would allow the consumer to achieve the initial utility with new prices. That means price ratio will remain same, and we need to find out new compensated income. So let us draw a line CE, new line parallel to CE, and I will explain it. So for that, okay, so let us say it is HK. Okay, first initially consumer was at this point. Okay, after the price decrease, consumer is at this point. Now this is total effect. Now we need to decompose the price effect into substitution and income effect. For that, we draw a new line HK parallel to CE in such a way that the consumer's utility remains constant at new prices. Okay, so we need to find out this point now, this tangency point. Now the movement from this point to this, let us say this is 1 3, this is 2. The movement from point 1 to 2 will be obviously the substitution effect because the consumer is on the same utility, on the same indifference curve. Okay, Now this HK line is a fictitious budget line only used to decompose price effect into substitution effect. And how do we do it? Since consumer has written here, we need to take away the income from the consumer in such a way that he is able to afford the initial level of utility at the new prices. Okay, so this budget line is shifted parallel in such a way that it is tangent to the initial indifference curve. That is, we are holding the utility constant here at new prices. Okay, now to achieve the initial utility with new prices, what we need to do, we need to equate MRS with new prices. So what we need to do here initially, we need to equate MRS between good A and B with the new prices. Price of A prime divided by price of B. Now we got this is equal to B upon A is equal to 2, or B is equal to 2A. We know that very thing also. Now since we want to hold utility constant as 1200, and then we need to find out, since we are taking utility constant at 1200, we need to find out the new bundle at utility level of 1200. So what will we do? So in place of utility we write 1200 should be equal to, so we have 40 times under root A. Let me write here under root A times B raised power. So B is 2A. Okay, so when we solve this, I don't have the space, we will get A will be equal to 21.21. Let us write it as A superscript C. So when we solve this, we will get 21.21 units. Okay, so the movement from this point to this point, so at this point consumer is getting 21 units of good A if we hold the initial utility constant at new prices. Okay, and we don't need to bother about good B here. Okay, we can also find out the value of good B. Plug A is equal to 21.21 in this, so we will get 2 times 21.21. we don't actually need this very thing. Okay, so we found out the initial bundle, final bundle, and compensated bundle. So this compensated bundle was only used to decompose price effect into income effect and substitution effect. Okay, so how did we found out this? So we held utility constant. So we held utility constant. Okay, and equate MRS between A and B at new prices, price of A prime divided by price of B. Okay, so if utility is constant in this, and when we solve this, we got B is equal to 2A. Then we plug this value B is equal to 2A into this function to get the compensated bundle here. Okay, now what is Hicksian substitution effect? Hicksian substitution is the change from the initial consumption of good A to this new consumption or compensated consumption, which is this. So let us say this was our A, this was A prime, this was A compensated. Okay, so Hicksian substitution is the change from the initial consumption of A to this new AC, which is our compensated consumption. Now what will be the substitution effect? From, since consumer is moving from 1 to 2 and we are on the same indifference curve, so it is the substitution effect. So the substitution effect will be equal to AC minus A, which is equal to 21.21 minus 15, which comes out to be, I have calculated it, 6.21. 6.21 will be the substitution effect. Now the movement from this point to this is substitution effect, And what will be the income effect? Income effect will be the rest effect, that is the movement from from this 2 to 3, which is from AC to A prime, which is A prime minus AC. So A prime is 30 minus 21.21, which I calculated 8.19. So this is our income effect, which is 8.19. Okay, because of the price decrease, substitution effect is 6.21 units of good A will be consumed more, from 15 to 21, and because of this price decrease, 8.19 units will be consumed due to the income effect. Okay, so I hope I have done justice to this video, but since I don't have the ample space here, I cannot explain all the things here. I have explained the income effect, the substitution effect in earlier videos also. You can check out those very videos. Okay, so please like, follow and comment on this channel. That will be only motivation for me to make more useful stuff for you people. Okay, so our substitution effect is 6.21. so this is the total change from this to this. It is actually 15. Okay, this is the price effect, the movement from this line to this line, 15 to 21, this is substitution effect, and the movement from 21.21 to 30, this is the income effect. So substitution effect is 6.21, income effect is 8.19. so it should sum up to be it should be equal to 15. Okay, so 15 units of change in the quantity is decomposed into substitution effect, that is 6 units are due to the substitution effect and 8 units almost are due to the income effect. Okay, so keep shining and stay blessed. Please give your valuable feedback and subscribe this channel. Thank you.